In this video, we're going to be looking at our work packet for section 8.3, radicals in simple radical form. I'm going to be doing some of the example problems with you so that when you're going ahead and doing your homework, that you're aware of how to do them. Notice at the top I have the radical form and the exponential form rules of the root of a product and root of a quotient for you. So let's look at the first one, the square root of 72. So the square root of 72 we know is 36 times 2, and 36 is a perfect square. So this becomes the square root of 36 times radical 2, and the square root of 36 is 6 times radical 2. And that is it. And if you would plug the square root of 72 and 6 times radical 2 into your calculator, they would come out as the same value. So all of these in this section are done the same way. They may take a little bit more work for you to figure out which number is the perfect square, but I think you guys can do it in algebra too. So now we're going to move on to example 2, using the product property to multiply square roots. So let's look at the radical 3 times radical 15. There are two different methods that you can employ here. And so for the first one, we can look at the square root of 15, which we know is 3 times 5. So I would rewrite radical 3 times the square root of 3 times the square root of 5. And the radical 3 times radical 3 times radical 5 ends up canceling the square root, and our final simplified form is 3 times the square root of 5. This can also be found in method 2. In method 2, because I have the same root of 2 in that square root, I can just multiply 3 times 15. And 3 times 15 is the square root of 45. And the square root of 45 can be broken down into the square root of 9 times the square root of 5. And the square root of 9 is 3 times the square root of 5. So both ways will give you the same rule, give you the same answer using two different methods and using the product property to multiply square roots. So go ahead and try 3 and 4 on your own. For example 3, we're going to be using the quotient rule to divide square roots. That rule's on the front page for those of you that don't remember. So if I am asked to find the square root of 16 all over 81, I know that the square root of 16 is 4, and the square root of 81 is 9. And so this problem is very simple, and it ends up being 4/9. And 4/9 cannot be simplified anymore. Let's look at the one below that's a little bit more challenging. If I have the square root of 15 all over the square root of 3, I can break that down into radical 3 times radical 5 all over radical 3. My radical 3's cancel, and so my final simplified version is the square root of 5. Pretty simple so far. Let's look at rationalizing the denominator. If we want to rationalize the denominator, and we're asked to find the square root of 2n all over 6. Let's do this difficult one, number 3. I need to multiply both my numerator and my denominator by the square root of 6. The radical 2n times the square root of 6 is going to become the square root of 12n all over 6. That then becomes 2 times the radical of 3n all over 6, and 2 goes into 6, so the final simplified version is the square root of 3n all over 3. Notice in this problem there was a variable. You just follow the rules, making sure that the variable is included in those rules. Let's go ahead and look at example number 5, simplifying radical expressions. If you look at number 1 and you watch the first video, you will be able to find that one solution. So let's go ahead and look at number 3. So number 3 asks us to find 4 all over 3 minus 2 radical 2. We're going to multiply by the conjugate, and the conjugate is 3 plus 2 times the square root of 2 all over 3 plus 2 times the square root of 2. When I go ahead and multiply across in my numerator, I have 12 plus 8 radical 2 all over 9 minus 8. And that simplifies to 12 plus 8 radical 2. From this step to this step, all I have done is multiply across. Let's go ahead and look at the very last type of problem on here. And the last type of problem is giving us a core concept that we need to understand going into Trig and Pre-Calc next year. And that core concept is when we're finding the principal square root of an expression containing variables, we need to make sure the result is not negative. And so for radical expressions where the exponent of the variable inside the radical is even and the resulting simplified exponent is odd, you must use the absolute value to ensure you have non-negative results. So let's look at example number 1. Example number 1, we have the square root of 30 times x to the 4th. 30 is not a perfect square root, but x to the 4th, if we take the roots of that, we can pull out an x squared. And then we are left with x squared times the square root of 30. Let's look at the next one. So for number 2, we have 54, x to the 4th, y to the 5th, z to the 7th. 54 is one of those values you might need to do some scratch work on the side. And so if we look at this value, the square root of 54 breaks down into the square root of 9 times the square root of 6, and that will simplify to 3 times the square root of 6. So, if I know 54 breaks down into 3 times the square root of 6, inside of my square, I'm left with 6. And out front, I will have a 3. Now I have x to the 4th, and the square root of x to the 4th is x squared, so that's pulled out. Y to the 5th is not a perfect, but if we remember our exponent rules, y to the 4th would pull out a y squared. And if we pull out a y squared under, we're left with a y. And for our z to the 7th, we're going to pull out a z to the 3rd, and we're going to be left with a z. And so, if you look above, I've included these rules for you. X, the square root of x squared, is equal to the absolute value of x. The square root of x to the 3rd is equal to the absolute value of x times the square root of x, and so on and so forth. And if we look at these rules, we used a 5th for our y, and for the z, we had x to the 7th, so we were able to pull out z to the 3rd. So what I'd like you to do is go ahead and solve the problems in this packet, and then we will continue doing some more challenging problems here in section 8.3.